Hello everyone, welcome to another edition of the Science Chef educational series on chemistry. In this video, we will be looking at the second part of our series on redox reactions titled Oxidizing and Reducing Agents. If you are yet to watch the first part of the series, that is the basic introduction to redox reactions, just click on its link in the description and voila, you will be learning a lot. By the end of this lesson, you should be able to define and identify oxidizing and reducing agents in terms of oxygen and hydrogen transfer, define and identify oxidizing and reducing agents in terms of electrons transfer and change in oxidation state, and finally, you should be able to describe a disproportionation reaction and list some common examples of oxidizing and reducing agents. Go nowhere, as we'll be right back after this timeout. Welcome back. In our last lesson, we studied the different concepts of defining and identifying redox reactions, but we intentionally did not mention that a redox reaction is one that occurs between an oxidizing agent and a reducing agent. So, if you want to learn how to identify these substances in a redox reaction, then endeavor to watch this video to the end. Simply put, an oxidizing agent is a substance that helps to oxidize another substance and becomes reduced, while a reducing agent helps to reduce another substance and becomes oxidized in the process. In this tutorial, we will be defining and identifying oxidizing and reducing agents using 4 different concepts. So the first concept we will consider is the transfer of oxygen atoms. In terms of oxygen transfer, an oxidizing agent is a substance that donates or supplies oxygen atoms, while a reducing agent is a substance that accepts oxygen atoms in a redox reaction. Let's try to identify the oxidizing and reducing agents in the redox reactions we learned about in our last tutorial. In the reaction between zinc oxide and carbon, the zinc oxide is the oxidizing agent because it oxidizes the carbon by donating an oxygen atom to it and becomes reduced to zinc metal, while the carbon is a reducing agent as it reduces the zinc oxide by accepting the oxygen atom from it and becomes oxidized to carbon monoxide. In the reaction between carbon dioxide and carbon, the carbon dioxide oxidizes the carbon by supplying an oxygen atom to it and becomes reduced to carbon monoxide, which makes it an oxidizing agent, while the carbon acts as a reducing agent by accepting the oxygen atom from carbon dioxide and becomes oxidized to carbon monoxide too. The next concept is the transfer of hydrogen atoms. In terms of hydrogen transfer, an oxidizing agent is a substance that accepts hydrogen atoms, while a reducing agent is a substance that donates or supplies hydrogen atoms in a redox reaction. In the reaction between hydrogen sulfide and chlorine, the hydrogen sulfide gas acts as a reducing agent as it donates a hydrogen atom to chlorine and becomes oxidized to elemental sulfur, while the chlorine gas serves as an oxidizing agent because it oxidizes the hydrogen sulfide by accepting the hydrogen atom from it and becomes reduced to the hydrogen chloride gas. In the reaction between ammonia and oxygen, the ammonia gas is a reducing agent as it reduces oxygen to water by donating hydrogen atoms to it and becoming oxidized to nitrogen gas. And oxygen gas is the oxidizing agent because it accepts the hydrogen atoms from ammonia. In terms of electrons transfer, an oxidizing agent is a substance that accepts electrons, while a reducing agent is one that loses electrons in a redox reaction. In the reaction between sodium and chlorine, the sodium atom loses an electron to the chlorine atom and becomes oxidized to a sodium ion, while the chlorine atom accepts the electron from the sodium atom and becomes reduced to a chloride ion. Hence, the sodium atom acts as a reducing agent, while the chlorine atom acts as the oxidizing agent. Now, in terms of change in oxidation number, an oxidizing agent is a substance that decreases in oxidation number or whose oxidation number changes in the negative direction, while a reducing agent is a substance that increases in oxidation number or whose oxidation number changes in the positive direction in a redox reaction. In the reaction between zinc and copper 2 ion, the oxidation number of zinc increases from 0 to 2, which makes it a reducing agent, while the copper 2 ion is the oxidizing agent because its oxidation number decreases from +2 to 0. Similarly, in the redox reaction between iron 2 chloride and chlorine, the iron 2 chloride is a reducing agent because of the increase in the oxidation number of iron from +2 to +3, while the chlorine gas acts as the oxidizing agent as its oxidation number decreases from 0 to -2. Apart from the reactions we have studied so far, let's look at some common examples of oxidizing and reducing agents. Other examples of oxidizing agents include oxygen gas, ozone, halogens, most metallic and non-metallic oxides, potassium permanganate 7, potassium dichromate 6, concentrated sulfuric acid, concentrated nitric acid, etc. Other examples of reducing agents are hydrogen gas, active metals, carbon monoxide, potassium iodide, lithium tetrahydroaluminate 3, sodium tetrahydroborate 3, etc. These substances act specifically as oxidizing and reducing agents in redox reactions. However, there are some substances that can act both as oxidizing and reducing agents in redox reactions. In other words, in the presence of stronger oxidizing K2Cl2O7, they act as reducing agents and act as oxidizing agents in the presence of stronger reducing agents like hydrogen sulfide. Examples of such substances are hydrogen peroxide, water, and sulfur dioxide. As reducing agents, hydrogen peroxide and water are oxidized to oxygen gas, and as oxidizing agents, they are reduced to water and hydrogen gas respectively. Sulfur dioxide, on the other hand, as a reducing agent is oxidized to sulfate ions or sulfur trioxide, and as an oxidizing agent, it is reduced to elemental sulfur. Finally, let's consider the following reactions: the decomposition of hydrogen peroxide to water and oxygen, the decomposition of water to hydrogen and oxygen, and the dissolution of a copper 1 salt in water to form a mixture of a solution of the corresponding copper 2 salt and a precipitate of elemental copper. What is common to these redox reactions? Can you see that in each reaction a single substance undergoes oxidation and reduction at the same time and therefore acts as the oxidizing and reducing agent? A chemical reaction in which a single substance undergoes oxidation and reduction simultaneously is called disproportionation. In our next tutorial, we will be teaching you how you can test for oxidizing and reducing agents in the laboratory. So, if you enjoyed this lesson, give us a thumbs up by liking the video and subscribing to our channel. We would also like to read what you think about our channel. Please endeavor to leave your comments and don't forget to turn on the notification bell to always be the first to get notified whenever a new video is published. Thank you for watching.